doesn't crash like it did yesterday morning, and then it was gone. I don't know what happened. It wasn't that it got knocked over. It just like it locked up, and then it was when I rebooted it, there was nothing. I offer you the opportunity to meet with me or the PAs over like the next 3 class days to talk about it. Oh, you didn't, whatever I said, whatever you asked, you didn't understand? Okay. I'm sorry about that. Let's fix it. All right. First couple items. One, regarding the exam, I've been sliding a little bit on what we're going to do there. So, as of a 5 or 10 minute conversation this morning, I decided that I would make, collectively, we decided that we would make half of the exam take home. So we'll do an in-class portion. Yeah, they were really excited about it. They had like, looking like in Slack, they've got this picture of me like for president with like a take-home quiz or whatever in the bubble. Like it's a fun image. They were really excited. Yeah.
We got a separate Slack channel for morning and afternoon. A little more separation.
Hey, I'm recording right now. They're gonna hear that.
That was Seth Erickson that said that.
So anyway, so they talked me into giving at least half of the exam take home. I discovered also today that a lot of your other classes, if not all of them, are giving take home exams, and so I'm sliding more in that direction then. But I do want to have an in-class portion that's going to be on a piece of paper. We're going to have to do subnetting and stuff like that real quick in class on paper. So that's going to happen. Yeah, do you want to ask me any questions about the exam at this point? Yeah.
Is it the same exact exam, just some of it we get to take home?
Well, okay. The exam has not been written yet, so.
So is it going to change? Is it going to be harder now?
It's probably going to be about 55 questions, true, false, multiple choice, take home, and then the in-class portion is going to be a bunch of solved stuff, like with tables and pictures and short answers. So.
And is the table
It's all going to be closed book. Yeah. So I've heard Dr. Wells does the offer that, if you want to have it be an open book one, I'll just make it ridiculously hard, but that sounds exhausting to me to make one that's ridiculously hard. So I'd rather just make one that's just moderately difficult and just say closed book.
Reading the take-home portion is like a test, like a time test, like we're used to?
Yeah, they'll both be timed. So the take-home one will be like 55 questions, multiple choice, and the in-class one will, I don't know, we'll do an hour. I'm not sure if we want to do an hour or an hour and 15 minutes, one of those. So, all right, other questions about that exam? Yeah.
Can we undo section 1's request and just have one test? Because now I feel like we're just going to have double the amount of tests.
It's gonna be. It's gonna be very similar. It's gonna be very similar in length and format as the exams in previous years. So I don't want to rob you of the learning opportunities. or the assessment opportunities compared to the people that have gone before you. But but at least rather than taking it to the testing center like they've done in years past, you'll get to take part of it at home. So that'll be good. All right. All right, so that's how we're going with that. So here's another one of those hot potato topics. So I try my hardest to make sure that there's not any pain points for people, that there's not supposed to be anything that causes undue suffering or distress. But I've gotten the subtle message that some people are feeling a little bit of stress and anxiety and pain related to the quizzes. And so I don't know that it's going to help to talk about it, but I'll say a few things about it, because I haven't thought of any solutions. So first off, the quizzes aren't worth very much in this class, and they do kind of let you know what you do or don't know that's important to me that you're probably going to find on an exam as a concept. So it's a nice signal. Another thing is, if the majority of the class doesn't get a particular quiz question right, then after the fact, I'll decide, okay, that was too hard. I didn't mean to mess it up. It was supposed to not be hard. It's supposed to be moderately easy. So if the majority didn't get it right, then later on you might see your quiz question scores go up because I check it and I drop questions that didn't have generally everybody getting it right. So there's that. And then I'll just kind of walk you through the process of how a quiz question gets created on my end. I start off with a particular topic and I have a general idea of what's important. So for example, FTP, File Transfer Protocol. Historically, that's a way of sending a document from one computer, typically a desktop client, to a server, another computer. There's the big idea. All right, so then I'll pop open the book related to a topic like that. And right here on page 219, it says FTP. I say, okay, what's something that I can ask about this? And so I'll see an italicized sentence there that says, so I'm not looking for something that's buried. FTP is an internet protocol for transferring files from one computer to another. So I'll stop and think about it for a second. I'm like, okay, how about this? For this question, I'll make one of the answers be transferring files from one computer to another, and another answer is going to be for transferring emails from one computer to another. I'm like, okay, I could stop right there. I'm like, but no, that would be too easy. So I'm going to go to the second half of this sentence where it says, you transfer between computers regardless of the hardware and software computers of the two computers. So it says regardless of the hardware and software of the two computers. Okay, I'll add that in as another part of the answer, and then I'll take the opposite of that. It's deeply dependent on the hardware and software of the two computers. And then I'll say pick whatever's right about FTP. So that's the intention of how the quizzes are supposed to come together. It's not, I know sometimes I might get a little bit carried away and ask something a little bit harder. Sometimes I think, well, what's the big idea, the overall idea? I'm like, well, it's this, so I'm going to ask that instead. But I'm not actually trying to trip anybody up. And if I do trip people up because a lot of people miss it, then like I said, I'll drop it. So anyway, that's what's going on with the quizzes. I don't have any way to make it easier, but I think chances are later on in this class, after the class, you'll look back on those things, you'll be like, oh, that's so easy, everybody knows that. So, especially after the exams. Thank you, James. Now quit slapping me before I put stuff up on the screen. All right, now let's move forward with stuff. Come on, you can do it. All right, let's try this again. Try unplugging, replugging in everything. There's a little red light on that thing up there. I don't know if that has anything to do with any problems. Alright, so I'm gonna try and see if any type of rebooting works there. The red light there says lamp. I hope that's not what we have a problem with. Anyway, what do you want to talk about while we're hanging out? Section 1 again. Anybody doing anything cool this weekend? Homework? Not so cool? Oh yeah, basketball. Alright, so that's not coming up right now, which is super lame. Let's see, can I get the front? Ooh, alright, so what do we got going on there? Alright, let me try some other options. What if I tried different ports and did VGA? This will take us a minute, but we'll figure something out eventually. Oh, come on, it doesn't quite fit. Eye roll. Yeah, so this is yeah, we're having like a technical video. We're having a technical difficulty video today. Isn't that just awesome? All right, well, what I can do is I have some USB sticks here. I can just move it over to here. It'll just take me in. No, I'll just, hold on. I'll just log in and open up Box. There's always a way to solve a problem. All right, so what else? Okay, so Gonzaga, yeah, I like that idea. What else?
Going skiing.
Going skiing? Nice. Is it still a good time of year to go skiing?
We went up north, so.
Yes.
Okay. So the 10 minutes that I was going to let you out of class early seems to be going away as all right.
Dr. Kettle, did you make a section 1 video?
I did not make a section 1 video. Alright, transport, NatPat, and then almost there.
You can stay here.
And we're back. And they have this great pointer that goes with this particular computer, but I don't see where it is right now. Oh, there it is. Woohoo! I got the power. All right, I like it this way because now I can walk around. All right, so anyway, last time we were talking about layer 4, and just really quickly, I was mentioning that the stuff about the ports is the most important stuff. Scott, that's awesome that you got that short haircut. It totally throws me off. All right, so random conversation. I just want to recognize that. All right, so yeah, we talked about how when you've got applications and sending data between 2 IP addresses, you can't actually get it to the right application on either side unless you have some additional information, and that would happen to be the port. There's nothing in the IP packet itself that is going to tell us where to deliver a packet once it gets to the computer, and in terms of distinguishing which program it's supposed to go to. And so I made the comparison that a computer is sort of like a post office where there are lots of boxes where you deliver content to. So every single computer has 65,535 TCP as well as UDP ports, which are potential destinations for your application data that comes across the wire. There's another depiction of that. Everybody's talking back and forth, not only with the IP addresses, but also using the ports so that we can distinguish which programs are exchanging information between the two things. I talked about how some ports are famous, that we commonly use them all the time, particularly as a destination as we reach out from our local computers to some remote computer. And then we have all these not famous ones, which are in a particular range where your operating system just randomly makes one up in a particular range to start a conversation between two different applications. I had to look up a list of TCP and UDP ports for famous stuff that's out there. And then the last thing I told you was to make sure that you memorize many of these famous ones. All right, so, and there in the TCP header is where we have TCP and UDP information. In just a second, we're going to be getting back onto your Raspberry Pis, so you may want to have those ready to go. Oh, there's that second. Okay, so, oh, wait a second. You can't see my computer. I can't PNC into my Raspberry Pi. It's going to ruin everything. What do I do now? So disappointing. All right, I guess. Pardon? Go to the live. No. All right, let me just.
You want to try using my computer?
It could be, yeah. If you've got one, I'd be willing to try it. This one has had some problems in the past, so it's possible that it's a connector. It's got the USB-C. Yeah. All right, let's give this guy a try. Try this one first. Hi. This is my partner in crime here. Sweet. Thank you guys. Teamwork. Love you. Love all of you. Okay. All right, so if you want to hit your Raspberry Pis, let's look at a web visit. So visiting a web page. Remember how I referenced that that Baby Shark song yesterday? I was in the Canon Center today, and there was some employee back there just shouting it out loud and proud, singing away. I was like, yeah. Okay, so I'm going to get ready to make a capture. I pulled up a website, I want to see the traffic happen. So I'm going to hit return on here, but I'm not going to do it yet. So I'm going to go over to one of my Wireshark windows. I'm going to start a capture, so continue without saving. All right, it's going. I'm going to go back to a web browser, and I will hit return so that this visit to a web page is being captured. And that's probably about enough time for it to be captured. And I will now hit stop. Ooh. Okay. I had it filtered there for a second, so I'm going to undo my filter. A lot of the traffic that you see happening right there is going to be related to the fact that I'm using VNC, so all these TCP packets are related to that. And I actually want to see my web browser traffic. I don't want to see that. So there's a couple different ways I could filter this. I'm going to do a sort right here by protocol, and I want to look for HTTP, which is going to be the web page visit that I just did. So if I go down there in alphabetical order, there it is. Okay, so I see that the source was my Raspberry Pi's address, 192.168.1.248, and the destination is the BYU Domains Reclaim Hosting address, 192, etc. And the command that was, the type of information that was sent was a hypertext transfer protocol package, and it says it's a get command, and that's, anyway, so that's how it starts off its conversation to retrieve a web page. What I want to call attention to is down here, we have our different types of frames and packets. So the first two relate to Ethernet. Then we have our IP packet, which with its source and destination address.
Can you make it bigger?
I wish that I could. I don't think I can make that go bigger, so I apologize. What it says right here is that there is a source port. So when I hit go in my web browser, there's a source port right there that says 40,708. My web browser just made that up. It along with the operating system just pulled it out of thin air and says, I'm going to use that as the return destination address. And the destination port is 80. So this is an additional packet or header of information that goes along with the IP packet. And then, not surprisingly then, the next thing that happens is there's a response back from 192.8.1, so that's Reclaim Hosting. It's going to my address, 192.168.1.248. And if I come down and I again look at my layer 4 header, the destination port is now 40,708, and the source port is 80. So all the stuff that I told you about conceptually, we can actually see it. Now, any questions about that? Yeah.
Wasn't source port, or wasn't port 80 one of like the input ones you were supposed to know?
Yes.
Where is it from? Like, is that like Yahoo or?
All web servers by default run on port 80.
All web servers.
Uh-huh.
Okay.
Well, yeah. By convention, when we start up a web server, so there's a configuration file. And when you start up your web server, technically you can have it run on any of the 65,535 ports. But by convention, it's usually as a configuration item, it says run it on 80.
Okay.
But in reality, you could run it on others. And so that's why when you do your local development, you do 8080 and 8081. You can technically load your web server on any port, but by normally, the famous port we link it to is 80. And yeah, and so if you do load your web server on a different port, just when you type something into your URL, you just have to do colon and then indicate the other port that you're going to be using. Yeah.
So is the source port and the destination port is like one on your computer and one on the like web server?
Yeah, the other network service that's out there somewhere.
So which one is your computer?
My computer has the local IP, well, in terms of the port or the IP address. So there's kind of two parts to that. The short answer is this is the packet that's the response back from the web server, and it says destination is 40,708. So I am the destination. And then where's the source? The source is from port 80.
If some company wanted to use a different port that wasn't 80, would that cause problems? Like when your computer sends a request, does it automatically assume that it's going to be on 80?
When you use a web browser, your computer automatically assumes that it's on 80 or a secure one like 443.
Okay. So you have to tell it somehow.
So if you change your config file on a server that you're running at work, and you change it so it's running on port 8082, the only way that people in this world, generally speaking, the only way that people are going to be able to visit that website through a browser is if you tell them it's on 8082 and they enter in your website domain :8082, and then it'll come up just fine. If they hit 80 and nothing's running on 80, they're just going to get some error message in the browser. So you need to know a little bit of extra information to visit the web page at that point. Yeah?
Just to follow up with Savannah's question, so on the line above in the get request,
So this was the initial request, yeah, from my Raspberry Pi out to them.
so it's flipped, right? So the destination port is the server,
The destination is port 80 in that case.
and that's at the server?
Yeah, on the other side, yep.
And then, okay.
And I'll do somebody already posted, well, I shouldn't say it. Anyway, I'm going to do a diagram on the board of this type of interaction in towards the end of class. And I'm gonna require you to know all the aspects of that diagram as well. So it'll be important. I'll remind you of the importance of it at that time. Okay, back to, I've got so many things up. How do I orient myself? Wait, okay. This one, then this one. All right, carrying on. Okay, here it's hot. Oh, well, this went past too fast. But anyway, so you can see highlighted here as you're having an interaction. Here's the famous port, so that's probably the public web server like Yahoo or Google. And then here's this weird ephemeral port that your browser made up while it was going to start a conversation with somewhere else. Okay, let's talk about vulnerabilities for a second here. You guys have been steeped in IP knowledge for a while now. You understand how the IP address is for IPv4, that there's a little over 4 billion addresses out there. And you're also aware that on any given computer, you might have 130 or so ports that are sitting open on that computer. So if you were a hacker, how would you go about probing a computer on the internet and seeing if it has any vulnerabilities? Mitchell?
See if you can access it through any of those ports.
Okay, and so let's maybe say that's part two. Part one, how would you maybe programmatically just find a computer that has a problem or a weakness? So there's 4 billion IP addresses. Where would you start?
You just start cycling through all the IP addresses and just sending
Yeah.
requests for information.
Yeah, computers are really good at doing these really annoying tasks. So you just start at the beginning of the IP address range and work your way up to the top. And then, so for every single IP address on there, Mitchell, what's the next thing you're going to do?
You're just gonna see if there are any ports that are listed.
See if there's anything running. Okay, and so something I was going to also mention is that for any service running on a port, typically if you probe it, it'll respond back with what it's running. So let's take something like Apache, for example. I don't know how many versions of Apache there's been, but they keep on updating and patching it. So let's just say that there's been, I don't know, 895 releases of Apache. Maybe there's more, I don't know. Whenever you probe it, it's going to respond back and say, on port 80, and say, yeah, Apache is running here, or Nginx is running here, or IIS is running here, and I'm running version 0.94, or 0.95, or 2.3, etc. All right, so how is that information useful to you as you probe each port?
Is there known vulnerabilities with each version?
Yeah, for all of the network capable software out there, if we connect to email, if we attach to an SSH thing, if we attach to a some type of social media service that's out there, all of them over time you end up publishing what are the vulnerabilities associated with a given version. So you just go out there, scan, hit every IP address, hit every port on each IP address, look for the versions of software that they're running, and then you find something that's old and with like widely known vulnerabilities, and then you attack it. And so all the time, every single IP address on the net is getting scanned, and they're constantly trying to break into every device that's out there. So that's the world we live in. All right, related to vulnerabilities, let's look at some right now. Let's find out what ports are currently open for business on our computers. So first off, I'm going to go over to the Raspberry Pi, and I'm going to use this command right here. So over to my Raspberry Pi. Okay, it looks like I ran this a little earlier, but I'm going to type that in right over there. Sudo lsof -i -p-n, and then pipe that to grep listen in uppercase. So it takes a little while to type that in. I'm going to have different stuff running on mine than you have running on yours. so should you type that in and hit return, what I'm able to see is over on the left-hand side, a list of programs that are running on my Raspberry Pi. And over on the right-hand side, I can see the ports that they're listening on. I'm not exactly sure, oh, I see, it's because it's IPv4 and IPv6. So there's port 5900, port 22, port 80, and then something that scrolled off the side of the page that I can't see terribly well. So I've got 1, 2, 3, 4 unique ports that are listening right now on my Raspberry Pi. If all of my Raspberry Pi were exposed to the internet, which is not right now, I only have 2 ports that are exposed, but if all of it were exposed right now, then hackers could be probing those 4 different ports and seeing like what versions of stuff I'm running, like what version of VNC I'm running, what version of SSH I'm running, what version of Apache I'm running, and then if they think that there's a vulnerability with that, then they'll try whatever exploits are possible. All right, so similarly, we can do the same trick on a Mac if you have one. So you can type in lsof-np +c crep listen. And so how do you think I found these commands? Pardon? Do I, oh, yeah, I probably do. So how do you think I found these commands? I Googled them. So I asked questions of the great Google and Dunham. I asked things like, like how to see open ports on Windows, how to see open ports on Raspberry Pi, how to see open ports on Mac. So I just type in a command like, I type in a query like that and I get back some command. So I run it and let's see if I can shrink that a little bit so I can see it more. Sorry. All right, so what I see here on my Mac, I can see Box is running, Report D, something with Adobe, VM REST, and Node. And so those are the programs that are running, and then over on the right-hand side, I can see the ports associated with there. So my Mac is open for business on port 7, it's open right now on 17223, on 5606, and then a whole slew of other ports it's currently listening on right now. And interesting to me at least is that I didn't intend to have anything node related running on my computer listening for connections. So I'm always goofing around, trying out some new programming sample code or tutorial, and apparently I've kind of left some things open on there is what I think is happening, and I did not intend to do that. All right, any questions?
How would you close it?
How would I close it? Well, there's probably a variety of ways. One way is that every process is associated with like a process ID. So I could do like kill/9, whatever program that is, or I could do something a little nicer. Well, I could go over into the start menu here and find that program for force quit. Or another thing I can do if I weren't closing it is I can wall it off from the outside world using a firewall. So I can technically run firewalls on most of my PCs and Windows, Macs, stuff like that. So probably next time I'll show an example of walling things off with a firewall. So in that case, even though it's running on my side, nobody can get in because I've put in an extra barrier there. All right. I actually kind of like the output a little bit better on Windows. So if you type in Windows in any command window or PowerShell, if you type in netstat, you will see your local port addresses that are currently being used, and then something related to a foreign address. There's another way to see this, but you can at least see the ports that are being used or you're connected to currently. If I go down here a little bit lower, this one's all translated into IP addresses, and then those are translated into IP addresses and ports here. So, one of the reasons why this is important is if you're getting hacked, if you look at this, you should be able to know that you're connected to somewhere that you don't intend to be connected to, sending out information, and that would be bad. Yeah?
What do all zeros mean on foreign address? That's what I have on mine. Like I just have like 10 in a row, 0, 0, 0, 0, 0, 0.
So typically where I can't be 100% certain in this case, but typically whenever we see all zeros in terms of an address, that usually is associated with our default place where we send our traffic. Like if I'm at home, the default place where I send my traffic ends up being associated with my router, like my Google router. Like that's where I go to for all my internet traffic. So there's probably more to be said there, but I won't be able to answer that better.
It's not like
right
a
now.
local host running, or could it be that?
I don't think so. I'd be happy to look at it later. Okay, so here's another way that you could run that. You could do netstat-b, and this one on Windows shows you the program that is running and then the local port that is associated with that local program that's running. So again, if you ran this command and you see some program that says, let's see, what's a country we can pick on right now without offending anybody in the room? Like we'll go with Ukraine. so because Odessa, like they're well known for just like lots and lots of hacking and stuff, and the dark web and all that stuff. So anyway, so if we see some program over here that says like Ukraine rules or Odessa rules, and then there's some connection to it currently on your end, you know that there's a problem. So that would be bad. Okay, so that port stuff is going to come up a lot. It's important. Slightly less important now is going to be the next set of material. So if you have some application, like to say for example it's a web browser and it has a block of data, if the data is too big to fit in a IP packet, then we have to break it apart. So our layer 4 header allows us to create segment numbers, sequence numbers that differentiate, that allow us to like separate this and put it in individual packages to send out. So there's kind of my depiction. So imagine you got this website, this web page, and it's huge. So you can't just send it in a packet anymore. You have to break it up into several packets. And so if you think about applications, not in terms of what we've talked about already in this class, but just starting right here, where you have an application has some data that's relatively big to send, it needs to break it out into separate packages that have numbers associated with it for reassembly. And TCP helps us with that. So what do I mean by huge? I mean 65,536 bytes. You notice that we reuse numbers a whole bunch in the technology space. It's like, hey, it's that 2 to 16 number again. It's back again. So somebody decided that IP packets should be no bigger than 65,536. So if your operating system notices that what you're sending is bigger than that, it's going to break it out into as many pieces as it needs to be broken out into. It's going to number them, and then it's going to continue on down the stack to add addressing information to it. Yes, Jefferson.
Like, how big is like relative to the different parts of the packet? So like the TCP segment, the IP segment, and that stuff. How big is the actual like data packet that's being delivered compared to the others?
The header, so the headers are going to be relatively speaking small. So it's just like, this is just it's your to from address in your error checking code. It's just a little bit added on to the segment. The TCP header or the layer 4 header right there is just really going to have your source and destination ports. Anyway, it's just a relatively minor amount. Anyway, so if this were my packet, there's going to be a little bit, just a tiny bit of information on there that represents the 3 types of headers, and the rest of it should be data. Most of it should be data. Yeah.
So I'm thinking of like when I email a picture, I don't know if the protocol is different with like SMTP, but like it'll say, oh, this picture's too big, like use a smaller size. Like why can't it just send
it can technically send it out, and regardless, it's going to break it up into little tiny pieces that are no bigger than 65,536 anyway. But anyway, it just gums up the system if you send stuff that's really big. It'll slow down servers and things like that. So they're just trying to have you not use as much of the bandwidth in essence. All right, so as it relates to segmenting some piece of data that's too big, we add to our TCP packet that header a little information about the sequence. Now I know I could test you on this stuff, but I don't find any value in it. You can see in the chapter that it says you start with a number like 1 and you add in the length, and then the sequence number becomes 301, and then you add that to the next length of the packet, and then it becomes 622. For practical purposes, you might as well just think about a sequence as being like you broke the package into 3 parts. There's part 1, 2, and 3. It's a little bit more complicated than that because the numbering is not sequential. It's adding on the size of the packet. But conceptually, just think about it as segment or part 1, 2, and 3. Yeah.
This probably doesn't matter, but when you make packets, you cut it off at the 65,000 or whatever. So if you're 1 bit over that limit, does it create a packet of 1 bit, or does it split them into equal amounts?
The packet sizes are uneven.
They're uneven. Okay.
Yeah, and we don't have to really worry about how that works. We just let our operating systems optimize whatever they think is the best in any given situation. But there's minimal sizes as well. If you only needed to send a byte, it'll add in some padding so that your package meets some minimal size. So there's a bunch of little adjustments that happen.
Okay.
All right, so back to Wireshark again. We can kind of kill 2 birds with 1 stone as we talk about this next concept. I want to talk about the sequence as well as the 3-way handshake. So going back to Wireshark, what I see I sorted this by protocol name, but I know from experience that this HTTP communication could not take place directly. The way that TCP works is there has to be a connection, what's called a 3-way handshake, to establish the connection between the 2 places in order for TCP to be able to accomplish its goals of being reliable for communication in case one of the packets gets dropped. So TCP is going to require that there's some communication that happens before what you see there happens, before the HTTP packets get transferred. So I am going to right-click on here, and I'm going to say conversation filter IPv4. So it's not colorized. Conversation filter IPv4. All right, so now it's given me a combination of TCP packets and HTTP packets. And now I'm going to furthermore make sure that I've sorted by packet number. Okay, so notice that my HTTP packet is still highlighted here, but there are 3 things that came before it. So in terms of setting up a connection between my Raspberry Pi and this server that's out there, let me go down to my TCP header here. I've got my source port, my destination port, and then importantly there's this sequence. So to start this interaction between the 2, it started with a sequence of 0. And that is from my computer over to the web server. The web server then in this next packet responds back. Now it says that the sequence is 0, but the acknowledgement is 0. Basically, the acknowledgement field holds the sequence number that I sent them originally. Then I go back out to them again, and now it says sequence is 1, acknowledgement number is 1. So they're kind of playing this little game of ping pong where you're sending the numbers back and forth and adding 1 to them, and that relates to being able to know what order things are coming in. If I go down much further here, in other areas of TCP, you see that the sequence and the acknowledgement numbers become a little bit different. So 1 in 520, 520 in 291, 291, 520. At any rate, the sequence and the acknowledgement numbers allow us, well, at least the sequence numbers in particular, allow us to be able to put something back together again that's been broken up into a bunch of parts before it was sent somewhere. Okay, 2 for the price of 1. Another thing I wanted to mention here is that three-way handshake. So if I look over here, in the first packet there says SYN, not as in like evil, but synchronization. So this is a synchronization packet, SYN. Then we have SYN-ACK, so synchronize, acknowledge, and then acknowledge. That sequence happens at the beginning of every TCP connection that happens. So if you're reaching out to some remote web server to initiate watching Netflix, those 3 steps happen. If you're reaching out to start some email communication, those 3 steps happen. If you're going to start communicating with some social media application, Slack or whatever, it's going to start with those 3 steps. Once those things are done, then it's ready to have reliable communications and capture any dropped packets and that sort of thing. So, yeah, those things about the three-way handshake and the numbering of the packets to put them back together again, that's kind of nice to know, but it's not going to change your world. In contrast, you got to know the port stuff. That you'll work with as a developer, or the only person who probably won't work with the ports is perhaps somebody who's just an outright manager over technology in some way. Even then, you might still have to know about it from time to time. Sometimes people will be using software and they'll be like, Dr. Kettles, I don't understand. Why can't I talk to my HoloLens or whatever while I'm using this consumer device? I'm like, well, have you checked your ports? And they're like, I don't know what you're talking about. I'm like, well, okay, you'll get to 404 later on. So, actually, that was a conversation I had a couple years ago from one of the junior core students first semester. All right, so highlighting that whole sequence thing and the three-way handshake thing. UDP is also a layer 4 header. It's different though in that it doesn't have like those sequences in there, and if you're actually using it in conversation, it's not, what was I going to say about that? So anyway, you don't need the three-way handshake and you don't need the sequence numbers quite the same. So with this one, you just have a lot less information in your header. You got the source port and the destination port, so that still matters. You got to indicate where the packet came from in terms of an application and where's it going for identification purposes later on. But this is a lot more lightweight. When I was doing an internship in '98 with EY, Ernst & Young, I was out there on the golf course with I don't know, it seemed like that kind of environment. I don't remember exactly. Anyway, there was this guy, he's a partner or something, and he was out there showing off for his friends. And so he's explaining to everybody what TCP is versus UDP. And so he's like, TCP is like this, hello. And somebody goes, hello. So that's TCP. Here's UDP, hello. Anyway, that was it. And he was right. That's how it works. With TCP, there's a lot of overhead in terms of you have to have an acknowledgement for every packet. UDP, you just send it out there, that packet, and if it gets there, great. If it doesn't, you have no idea. And so in terms of a strategy, as somebody who builds technology, you might want to use UDP for example, if you're doing a broadcast. If you're like, if we drop a little pixel in the movie that we're showing you, it's all good. But if it's a web page, you don't want just parts of the web page not showing up. So you do use TCP/IP for that case, so that if something gets dropped on the way over there, it gets re-requested, and ultimately the whole page gets delivered. So, other stuff, lastly, related to this, we've now talked about the fact that we have this data that we want to send out, and we keep on adding in a little bit of information, a different header, depending on which. And they relate to the different layers of the OSI model that we're talking about. They each add in some additional stuff. Here's some, some official names that will go along with that. Something that jumps out to me from here is it says maximum transmission unit. I want to talk about about that for a second. Depending on the packet that you're using,